Hi and hello to everyone. In this video, we are going to discuss about a problem from angle modulated signal. Okay, the question is an angle modulated signal is given, right? Whose carrier frequency is omega c 2 pi into 10 power 6, and the angle modulated signal is phi em is equal to 10 cos omega ct plus 0.1 sine 2000 pi t. Okay, this angle modulated signal is this is your angle modulated signal. Okay, right. Briefly we will see what is an angle modulated signal. An angle modulated signal is given by this expression AC cos theta I t. Okay, you can classify angle modulated in two types. One is the phase modulated PM, another is the frequency modulated FM. Okay, and this is the relation, right? If theta I of t is omega ct plus kp m of t, right? This omega c is the carrier frequency, this kp is a constant, m of t is the message signal. If it is a frequency modulated signal, instead of constant kp we have a constant kf. The message signal is integrated. Okay, integral of message signal. Okay, this is the difference between the phase modulated and frequency modulated signal. Together they are called angle modulated. Okay, now the question is about the angle modulated signal, right? Okay, so from this what you have to do, you have to take the theta I. Okay, theta I. What is theta I? If we compare with this expression phi em with this expression, we can find out what is AC. AC is 10. What is theta I? So theta I is this term cos theta I of t. So this is your theta I of t, which is omega ct plus 0.1 sine 2000 pi t. Right. So theta I is the instantaneous angle. Instantaneous angle. Okay. Now the first question is about the what is the power of the modulated signal. Okay. For the power of the modulated signal, it is power is given as the amplitude square, that is AC square divided by 2. What is AC in this case? It's 10. So 10 square divided by 2, which is 50 watts. Next, what about the frequency deviation? Next question is about the frequency deviation. To finding out the frequency deviation, we need to find out the instantaneous frequency. Okay, so we know the instantaneous angle, which is theta I. From the question we have taken it is omega ct plus 0.1 sine 2000 pi t. From there we can find out the instantaneous frequency, which is omega I. Okay, this omega I is the instantaneous frequency. Instantaneous frequency. Okay, in radians per second. Remember the frequency we can say in two ways. One as omega, another as f. Okay, for omega the unit is radians per second. For f the unit is hertz. They are omega and these are f1 related by omega is 2 pi f. Okay, so we have theta. So if I differentiate this theta with t, I will get omega I, which is radians per second. So you differentiate this term omega ct. If you differentiate with respect to t, I will be getting omega c. So 0.1 sine 2000 pi t. If I differentiate, I will get 0.1 sine. If I differentiate this cos, then inside the braces we have 2000 pi t. So I will be getting multiply with 2000 pi. So I differentiate this term with t. I will be getting this. Okay. Now this is about your instantaneous frequency, right? Now the question is, what is the frequency deviation, right? So this is the carrier frequency. This is the carrier frequency. Omega c is your carrier frequency. From this frequency, how much it is deviating? How much the frequency is deviating, right? So what is it deviating? It is deviating by this entire term, right? So this cos term, you know, the cosine value, the maximum value is 1. That is the maximum value is 1, right? So the maximum deviation is, if this is 1, so omega c is deviating up to 200 pi. Okay, so omega I, that's a maximum frequency would be omega c plus 200 pi. So what is the maximum frequency deviation? From this value omega c, it is deviating up to how much? Plus 200 pi. So the maximum frequency deviation is 200 pi. Okay, so the question they are asking in del f, right? Delta f. So it is delta of omega. So we convert delta of omega delta f. This is the relation. del omega I can write as 2 pi del f, right, is equal to 200 pi. So del f is equal to 100 hertz. This is the frequency deviation in hertz. Suppose they are asking in frequency deviation in del omega, the answer would be 200 pi. Got it? Okay. The next part of the question is, I think they are asking about the phase deviation. They are asking about the phase deviation, right? What is a phase deviation? So this is the phase angle. Instantaneous phase angle is given as this. Okay. So what about the phase deviation? So this is the phase phi, right? Phi I of t. So we know that omega ct plus phi, that is a phase angle, right? So phi I of t is 0.1 sine 2000 pi t. What is the phase deviation? The sine term, the maximum value would be, we know for the sine term, the maximum value would be 1, right? For the sine term, the maximum value would be 1, right? So how much the phase angle is deviating? This is deviating by 0.1. See, omega ct plus 0.1. So del phi, that is the instantaneous phase. This is not phase. You see, they are asking the phase deviation. It's not phi I of t, right? So the correction here. It's del phi. It is del phi. That is in the question, right? So del phi is 0.1 radians. Okay. The next is, what about the bandwidth? Bandwidth, we know the relation is it is 2 times del f plus fm. What is del f? The frequency deviation. We have found it to be 100. What is fm? That is the message signal frequency. Okay, from the question we can easily find out what is the message signal. You come to this expression, right? You compare, one second, you compare, yes. The message is what? This is the message signal, omega ct plus kp m of t, right? So if you look at the question, this would be your message. This would be your message, right? So your omega m is 2000 pi, right? So omega m is 2000 pi. Okay, so we need fm, right? So 2 pi fm is 2000 pi, is fm is 1000 hertz. So 100 plus 1000 is 1100. 2 times 1100 is 2200 hertz. This is the bandwidth. Okay, I hope you understood this problem. Any doubts, you please ask in the comment section. I will be very happy to help you. Thanks for listening.